So how's it going, class? This is Mr. Estrada. It's 11:30 and time to do some physics. So hopefully I'm on the screen correctly. If not, I'm sorry, I can't really see myself, but I know it's recording my face. Here's the thing that you guys saw earlier. So let's play around with it. So you can move the ladybug and you can spin this thing. So when you first open it up, you can spin it and you'll see like two arrows, an acceleration, a velocity. Let's get rid of the acceleration one. And let's reset it and start it over. So there's the velocity. Things that you can also do is add a ruler, get rid of a ruler. And then right here on the left-hand side, it says angle. Picture this like a circle, 0 degrees because it's not moving. Then I move it 90 degrees and it says 90 right there. And then I move it 180, half the circle. And then 3/4 to 70, and then 360, one complete revolution, one complete rotation. So then I go more, and it should be 450 because each one's 90 degrees, another 90, and then it should be 540. I'm going to reset it. Another thing that we can see as I spin is the angular velocity. And let's pay attention to that. Angular velocity. Angular velocity. That is not linear. And that's the point of this, to tell the difference between linear and angular stuff. So now that we got acquainted with this and how it works and all the different numbers, let's look at the question. And what are you supposed to get from this question? So it says directions. In this activity, you must include values that you measure and show example calculations to support your answers to the questions. Include examples that use both bugs in different locations. Forgot to start the timer. Number 1, write a story about the bugs rotating on the turntable. In your story, include how to find the distance the bug travels, the arc length, and the angular displacement. So don't worry about the story right now. Let's just try to figure out how to find those two things. So I want you to, when you say arc length, think of that as the circumference. Arc length is the length of the arc of the circle. That's the circumference. Another way to think about that is how much that bug actually moves, the distance it moves in the circle, the distance, the displacement, the linear displacement. So let's talk about how to find that. The arc length, the displacement, the circumference. So yesterday we did an exercise and you guys told me that the equation for the circumference was 2 pi r. I'm sorry if you can't see that. So we put a ruler right here. We see that the radius of the ladybug right now is 2 pi. The radius is 2. So that's going to give me a circumference of 12.56 inches. 12.56 inches. Then when I move the bug over here to the end, that's 4 inches. So circumference 2 pi 4, that's going to give me a circumference of 25.12 inches. 25.12, that's the circumference. So let's talk about what that means exactly. We're talking about the arc length right here, the linear displacement, the linear distance, how much it moves. So when this bug is at right here at the 6, sorry, not the 6, at the second circle, it has moved at this point half the circles, half the circumference, so it's moved around 6.25 because the whole circle was 12.56. And then it moves all the way over here, and I stop it over here and went one whole time around. So the arc length, the distance that bug traveled, was 12.56 inches. When I move it over here, it goes one time around. It goes one time around. It goes one time around. And at that point, it's traveled 12.25 around there. Let's say it's exactly 25. And then once it comes back all the way around, that bug has traveled 25.12 inches. That's the distance it's traveled. That's the arc length, because we're thinking about this, the distance it traveled in a circle, the circumference. So now let's connect that to the second part, the angular displacement. How can we find the angular displacement? Well, the angular displacement we're going to find from right here on the left hand side, right on the ruler, it says degrees. And let's look how that before the linear displacement, the bigger the radius, the farther you were. And let's see how that changes outside over here. So I'm going to reset it, and it's at 2. And when it goes all the way over here to the end, it went 180 degrees. That's the angular displacement, how many degrees it went. And I'm going to reset it, and I'm going to put it over here at the very edge. And it's at 0, and then when I go all the way over here, from one end all the way over here, the angular displacement is 180 degrees. So the angular displacement didn't change based on where the bug was, but the linear displacement did change. And let's look at that relationship that we talked about yesterday. Linear displacement is equal to the radius times the arc length. This relationship right here. So both bugs traveled the same degrees around, 180, but different radiuses. That's why we got different displacements. The bug that had a bigger radius, farther outside the circle, traveled the bigger linear distance, but they both traveled the same angular displacement, the same degrees. So think about, maybe that will make it easier to understand. Angular displacement is the degrees of the circle the item is traveling. And then the displacement right here is the actual circumference, the actual distance it's traveling, not the degrees, but the distance, the perimeter. That's number 1. So suppose you were given a statement that all points on a rigid object have the same angular acceleration and the same angular speed. How could you use the bugs in the Ladybug Revolution to test that idea? Well, let's look at it. So here's one bug right here at the very edge, and here's another bug towards the middle. And let's just have this bug by itself. I'm gonna spin it. And look how fast it's going. 227.3 degrees per second. That's the angular velocity. Video is gonna stop. I only record 10 minutes at a time with this free thing that I got. I'll see you guys in the next video. The next video, I'll finish with the rest of the exercise. That first part, number 1, was the longest part. See you guys later. Now I'm just waiting for the time to run out, so let's wait it out and just end the video. This is getting awkward now.